Hello! Welcome to 1.2 Speed and Velocity Honors Physics lesson. I'm your host, Mr. Hernandez, and hopefully you can hear my voice because before you couldn't hear my voice, so hopefully now you can hear it. All right. So let's go ahead and start this off with the difference between speed and velocity. Speed is basically how fast an object travels, whereas velocity is dealing with how fast it travels, but it also includes its direction. So it's a vector quantity. Just a quick note here, when we talk about velocity and speed, we're going to be talking about instantaneous velocity and instantaneous speed for the time being, and that's how fast an object is going at a specific moment in time. All right, as an example here, I got Cletus and Sally, and they're traveling at the same speed, which is 45 miles per hour, excuse me. But one is negative, one is positive. So you might remember from section 1.1 where we talked the difference between negative and positive. So because Sally is going north, that is considered the positive direction. And because Cletus is traveling south, we're going to consider that the negative direction, assuming everything is from this reference point. And we're just going to use those basic terms where north is positive, up is positive, right is positive, east is positive, and then everything else is negative. So west, south, down, and left, we'll always consider those negative. All right, average speed. Formula for average speed here is the distance over time. Average velocity is going to be the change in position over time. And as long as that velocity remains constant, which it will in this section, then your velocity average will equal your velocity. It does change later on when we start dealing with acceleration, but right now everything is constant, everything is steady, so no need to worry. All right, suppose you have a bus driver here. His name is Otto, and he's driving all the way from Detroit to Chicago. It takes him 5 hours. I clicked on pen. It took a second. There you go. All right, it takes him 5 hours. So in order to figure out his average speed, we're going to go ahead and take 300 miles, divide that by 5 hours, and we should end up with 60 miles per hour, or mph is fine as well. That's for average speed. Now, as far as velocity goes, take a look here. So we still have Otto. He's still driving, but if you take a look at this map of Michigan and where Chicago is, we can actually draw a straight line from Detroit to Chicago, and that's only 200 miles. Now, obviously, we can't drive through Lake Michigan, but displacement-wise, our displacement is only 200 miles. So delta x equals 200 miles. And technically, that's negative because they're traveling west. So our velocity then, or our average velocity, is going to be negative 200 divided by 5 hours, because it's still going to take him 5 hours, even though he's only 200 miles away. So that should give him a negative 40 miles per hour as his average velocity. All right, units here. We have velocity. So velocity we're going to keep as meters per second, or sometimes you might see it as miles per hour, but we're going to try to stick with meters per second since that is the standard unit of measurement here in the science land that we live in. Displacement / distance, we keep that as meters, and time is seconds. So we'll just keep that as seconds. Sometimes you might see it as hours or minutes, and you just have to convert. All right, that ends physics lesson 1.2, and hopefully everything is working out okay on your end. I will see you later. Goodbye.